Now that you have an arsenal of components under your belt, the next step is going to be considering where these components might fit into your own projects to improve your productivity and workflow. So I have a few examples that I wanted to show you about some ideas of where you could really start taking this. But before that, let's recap very quickly what we've covered through the process of this course. So we've started by taking a look at where the components are already found and utilized within the engine. And for some of you, that could come as a little bit of a surprise of just how many of these components are already utilized in the standard projects and examples throughout the engine. We've then taken a look at when and why we might use components and making sure that we're really not looking at this as the only approach for your projects. It can definitely be a good approach, but there are the pros and cons to balance when using any kind of approach or architecture for your software development. So this has come with the considerations, the things to take into account when working with components, such as the extra memory cost it could take, the extra performance at runtime if you're not handling those extra events that are going to be triggered on top of the standard actor events that those components will be housed on. Then by looking at the different types of components, again, we've looked at some things that I think can be overlooked of just some of the nuances between actors and scene components, and again, some things that you may have been working with already and just not really considered exactly what it meant or why they were in certain locations and things like that. And we then began wrapping all of this up by creating our very own custom reusable components, giving us an example of how we can implement the component specific syntax, the different function calls and overrides that we can provide for our component creation, implementing them and setting up the properties exactly as we want them to be on our components, as well as how we want them to act and be set for the owning actors. So a couple of things that I've been mentioning throughout the process of the course and didn't really seem relevant enough at the time to break away from the topic of the set modules. But that is something called the emergent gameplay or the emergent game design that I kept mentioning. Now, for those unfamiliar, this is a little bit more of a game design kind of concept that you've seen, and again, maybe not considered in a lot of games such as the Zelda games, games like Deus Ex, and even games like Half-Life. And at the very core of what this means, it is when a set of smaller, kind of independent mechanics work together to create unexpected results and mechanics that even the designers of the game may not have kind of envisioned them to provide when creating the different components individually. So as a very quick example, in Half-Life, a lot of people are familiar with the crates and the sentry turrets. These are two very unique, separate things from each other. But because the crates have the concept of physics and blocking mechanics and destruction kind of programmed into them, as a lot of other things in the game do as well, and the turrets are, again, programmed to fire at and apply damage to anything that it hits. So this is where that kind of breakdown of not having it specifically look to damage just the player. The turrets could potentially damage the enemies, the crates. This is how you get systems where people will carry a crate through a level to block the turret fire. So these are two different systems, but they make a kind of emergent gameplay from the use of having them work together. Now, the alternative could have been that Valve program this type of thing and just have it so that the turrets are only tracing for character types, which means they might damage the player and NPCs, but maybe they go through crates, or maybe it doesn't damage the crate, which means you can hold it indefinitely. But instead, what we have is after a certain amount of hits, the crates will get destroyed. So again, that adds another layer of this kind of complexity, where you then have to go down and hunt another crate or another object to carry past the turrets. So this is the idea of emergent gameplay. And this is the kind of thing that getting more comfortable with things like components and interfaces and this reusability of mechanics and logic can really help to expand your gameplay and allow for these kind of flexible systems. Some more examples might be from things like the Breath of the Wild game, where in puzzles like this, the designers almost certainly intended you to use these two metallic objects, these two spheres. And the idea, of course, is to pass a charge between these. But because everything which is metallic in the game has this magnetic property to it, some kind of conductivity, it means you can do this where you can lay a bunch of metallic weapons and objects along a path and create a different way to get this conductive chain going from one point to another. So this is a kind of another emergent system where by having everything kind of make sense and be magnetic when they are a metallic object, this allows players to work out different ways to approach the same end goal, which can add a lot more replayability to these games. So another kind of more real world example I wanted to provide is a project I've worked on in the past as someone who creates very kind of quick prototypes for different companies just to get the idea of whether a project would be viable to proceed with or not. Again, this kind of workflow can prove super useful. So in this game, the idea was to create a very small, maybe even kind of mobile focused game for replayability and very easy to pick up mechanics. So you fire a missile. The idea is to get as many of the blue targets as possible in a single run out of a set number of lives, which are the number of missiles you have remaining, and then to finish off by destroying the red target at the end. Now, the way that I've used the destruction component in this, very similar to how I've kind of made a simplistic version for the project here in the course. They will have the concept of things like the effects to play, whether to trigger camera shake, whether to trigger sound effects and particle effects. And we can see that things like the blue targets will trigger just a particle. Those enemy tanks at the bottom can fire their own missiles, which will just create a particle and a small sphere of destruction. So if your missile is within that sphere of destruction, that will be destroyed too. If the barrels, which are sat along the ground there, are in that sphere of destruction, then they'll do their own thing, which when their destruction component is hit, they will fly off and provide some force. And again, they'll then blow up and provide another destructive sphere with some extra particles. Then in comparison, if you hit the tanks, then you get kind of a cluster bomb come out. Each of those clusters will have their own kind of destruction logic as well, as do the different missiles that you can fire. So all of those will also blow up, provide a particle, some screen shake, and then the cluster bombs as well. So the idea behind this is a perfect run would be having just one missile fired, you hit all of the blue targets as you go through, and nothing is really destroyed. However, you can do this in a very different way, where you fire a missile, you hit a wall, your clusters will trigger the barrels will explode something else, and you can complete the level just by having a barrel fly into the final target. So this is one of those things where everything interacts with everything else, and you can kind of completely mess up what you were doing, but still pass the level with a success. Maybe not a perfect, but you can get through each challenge in very dynamic ways. So this was made over the space of a few days, and by using this reusability, I was able to very quickly show that we could extend the type of logic and the mechanics available in such a small game to be kind of very dynamic and really give people an idea of how flexible they could make the challenges and the different levels by using and integrating different types of explosive objects, whether that be the tank, the barrels, the cluster mines, or the missiles that you fire yourself. So these are just examples I wanted to provide to really bring all of this together and show where this kind of theory that we've been looking at can really be brought together for very real world examples of projects and the flexibility that it can allow those projects to undertake. So I hope that you've enjoyed this course and are looking forward to taking these concepts and theories a little bit further into your own projects. And remember, you don't need to stop just with the components I've provided in the demo here. If you look back at the old live stream that this was inspired by Zach Parrish, there are other components you could very easily make and integrate into this kind of system with the demos I've provided. So he also provided things like the score component, which could easily be synced up with when something is destroyed, ticking whether or not it needs to provide a score, how much, and communicating that something like the game mode. So all of that is kind of ready for you to start plugging and playing with new components as well. And hopefully now you have the understanding of the syntax, the nuances, and the ways that you can implement your own components to really build off of the content in this course. So I hope you've all enjoyed the content in the course. Thank you for following along, and I look forward to seeing you again in future content.